Okay, so let's get going on day 2 of the chapter 2 review. So we're going to do number 7 and number 8. Okay. All right. So looking at number 7, we're getting into obviously section 2.2. Now we've got this word standard in front of normal. Okay. And so when you have standard in front of normal, this is talking about our distribution that's normal, that follows the 68, 95, 99, 7. But the mean of the standard deviation is 0, and your standard deviations are whole numbers out in those directions, right? And these are all z values. Okay, so that's what the word standard normal means. So we're going to use table A. Some of you are using a computer program just online. That's fine. You can continue to do so, but you're not going to get full credit because that's not what I'm teaching you guys to do because we're not together, right? So I need to check for level of understanding. So make sure you're using table A. You can find this. I posted a PDF in front of the quiz, so you can always use that. I'll put another copy in the class folder as well. Okay, so we're looking for, we've got a normal distribution that follows in each of the following regions. In each case, sketch a standard normal curve and shade the area representing the region. Okay, so we're just going to sketch these 4. Okay, pretty easy. And so for number 7, zoom out here. We've got the first one, and that's a z-score that's less than or equal to negative 2.25. And so all I'm looking for is your symmetric graph. You know this is 0, negative 1, negative 2, and then you would just put here negative 2.25, and you should be sketching all of those z values to the left. And so it's this tiny amount that's underneath the curve to the left of that value. Okay. B asks you to do z is greater than or equal to negative 2.25. And so all that would change is you're still way back here at negative 2.25. But because of your inequality symbol, this would be a much larger probability because it's all of the data that falls underneath that curve to the right. Okay. This would actually be exactly 1 minus whatever that one was. Okay. And then C, we're talking about z greater than 1.77. And so I would look for standard normal. It's out here somewhere, 1.77 greater than. You still shade. Don't get confused if it doesn't have an or equal to. It's still the same exact picture. So don't worry about that. Okay. And our last one here would be from negative 2.25 up to 1.77. And so now you have the standard normal with a mean of 0. We're back here at negative 2.25 and over here at 1.77. And visually, z is in between these two values, right? So you want to think about the area between those two values. Okay. All right. So then when we move on to number 8, it's called working backwards. And I use that language too in your hints on the quiz and so forth. So working backwards, you guys will know you're working backwards because what you're starting with is a proportion like 0.8 or 80th percentile, which is 80%, which is 0.8. Okay, so they could either give it to you as a percent or a probability, which is a number between a 0 and 1. Okay, and we want to find the z value, okay, at the 80th percentile. Oh, you know what? I'm backing up here. We were supposed to use table A to find those proportions, so we'll have to go back and do that. Okay, so let me finish this problem, and then we'll go back to 7. So 0.8, you're working backwards. And so if you are given this standard normal curve, 50% of your data would be right in the middle. And so we're just going to do something like that. And we're going to notate here that, look, this is a proportion, P equals 0.8. And so we need to go backwards to find what's the z value that corresponds to that. Well, the way you do that is you go to your table A values, and you're going to find 0.8 in the middle here. And you can see right here, 0.8023 is really, really close. So is 0.7995. This is actually closer. I would accept either of these, right? So your answer here is going to be, you come over to the left, z, right, is equal to 0.8, and then you've got 0.04. So when you combine 0.8 and 0.04, you get 0.84. Okay, so this would be 0.84. Okay. All right, and then for B, you're supposed to find Z, again, such that this is the same as 0.35, right? 35% as a decimal, are greater than it. Okay, so greater than it means you would go here. This is B, this was A. Okay, greater than 0.35. So you do your sketch. This is 50%, so we'll come down here somewhere, and we'll notate that this area, it's greater than. So we're going to come up to the other side, right? 35% is greater than that value. So again, we're looking for that z-score as our answer. Well, how do I use table A to do that? This is a simple procedure where you know that the table A only gives you the less than amount, this left-hand value. Okay, and so if this is 0.35, this must be 0.65 because that makes up a total of 1, right? 100% of your data. Okay, so let's go use table A to find that value. And 0.65 is going to be somewhere, that looks pretty dang close, 6.5, that's probably the closest. Okay, so if I go left, I'm over here at 0.38. And so you get your z value as 0.38. Okay, so again, they told us 35% or 0.35 above. You use that to find what's called the complement, 1 minus that value. And then you go to table A and you work backwards to find your z-score. Okay, so that's your procedure on those ones. Okay, let's go back and revisit this question number 7 because we were actually supposed to find the value. So how do I find the value to the left of negative 2.25? You just go to your table. You need to find the negative values, and it's negative 2.2, and then you got to come over here to 5. So right there would be 0.0122. So this value would be P equals 0.0122. Okay. Now, to find greater than, we talked about this. If this little tiny amount that we found is 0.0122, the other side would just be 1 minus 0.0122 to get us 0.9878. So this probability here is 0.9878. All right, how do I find above 1.77? Well, what we can do is use table A. Let's go to a z-score of 1.77. So I'm on table A, got my z-score, 1.7. All the way over here is 1.77. So that is 0.9616. Now, remember that 0.9616 is this, right? It's to the left of that value. So I would say that this is 0.9616. And so right here, again, using a calculator, 1 minus 0.9616 gets me the other proportion, which is 0.0384. Okay, so we're finding proportions which represents the area under the curve in a particular place. So our last one down here that we would have to find is this combined area. And so the way that we do that is we think of 2. Let's find first 1.77 all the way to the left forever. We just found that. It's right here, 0.9616. Okay, and then we're going to subtract off negative 2.25. We did that up here, right? We're going to cut off this little bit at negative 2.25, which was 0.0122. And so our answer is simply that guy minus that guy. So you type in 0.9616 minus 0.0122 for an answer of 0.9494. Okay, so that's everything you would need to use for table A. Table A is either finding proportions, which can be turned into percents, given a z-score, or given a proportion to start with, work backwards from your table to find the corresponding z-score. All right, more to come.